The latest update to the planetary boundaries shows us that we're facing multiple environmental crises, each of them threatening the balance of our planet. But here's the thing, none of the boundaries exist in isolation. They're all connected, interacting in complex ways, and sometimes amplifying each other. If we're going to effectively tackle these issues, we need to understand those interactions. Here you can see some of the key interactions between climate, land, and water with strong empirical evidence. However, current measures of environmental impacts often focus on carbon emissions, or if they do consider other factors, they do so in isolation. So there's a need for a metric that accounts for these interaction dynamics and help us gain a more nuanced understanding of the impact of our economic activities on the planet, so that it can guide our investment decisions. The Earth System Impact Metric, which from now I'll call ESI, addresses this need in 5 novel ways. First, it accounts for Earth system components other than climate, specifically accounting for the land and water boundaries. Second, it accounts for the interactions between these Earth system components that I showed you before. Third, it distinguishes impacts on land and water depending on their location, which is extremely important as impacts on the Earth system will vary tremendously depending on where they happen. Fourth, it accounts for the current state of regional boundaries, meaning that land and water use will have higher impacts in regions that have been heavily degraded already. And fifth, it scales impacts relative to the planetary boundaries, which allows us to assess the significance of these impacts. So, to summarize, the ESI allows you to measure the impact of your assets in relation to multiple planetary boundaries while accounting for your assets' location and for key Earth system interactions. And in order to use it, you only need to have 4 data inputs, which are location of your assets, carbon emissions, land use, and water consumption. And here's what it might look like in practice. So this is an example where we tested the ESI metric on a sample of mines. So armed with the necessary input data, the tool can do 2 things. First, it calculates the total impact of each asset, which you can see on the last column to the right. And second, it tells you which of the 3 pressures, so carbon, land, and water, is contributing the most to that asset's impact, which you can see in the 3 contribution columns, where these contributions will depend on the specific operation and on the location of each asset. In this table, you can see that mines are ordered according to decreasing total ESI. And for each mine, the contribution to total ESI are colored to help you identify what's contributing the most to impact. So for example, for the first 2 mines, water is contributing the most to ESI, while for the third one, it's land use. One thing to note is that ESI values are scaled so that an ESI of 1 million would imply pushing one of the planetary boundaries from their pre-industrial level to their boundary threshold. So an individual mine's score would be relatively small in comparison to 1 million. And that's because no mine or company will single-handedly be surpassing the planetary boundaries. But of course, that doesn't mean that it is a small impact. Here's a plot with the full sample of mines we analyzed, again showing how the ESI can be used to identify the most harmful assets and what's contributing to their impact. This can help you focus your mitigation efforts on the most harmful parts of your operations. This plot has the exact same data as the one before, but instead of being ordered by ESI, they're according by descending carbon emissions. And it can help us see how, if we were to prioritize mitigation efforts based only on emissions, we would actually miss some of the most harmful assets, which look like average or low emitters, but have high impact contributions from their land and water use. So this plot really exemplifies the added value that one can gain by using a tool like the ESI to measure their assets' impact. And this is just one of the many ways the ESI can be used. To give some more examples, companies could use the ESI to choose locations of their future production site, or as a factor to evaluate different sourcing locations and suppliers. Impact investors can track how their investments are reducing harmful impact over time, and they could use the ESI for that. Or banks or private equity investors could better evaluate the impact of potential loans or investment opportunities. We developed a prototype version of the ESI that you can access with the QR code or the link below, where you can learn more about the methodology behind the ESI, download the Excel tool, and explore other related resources. There's currently lots of work going on further developing and improving the ESI, as well as testing it with corporate and financial actors. So if this sounds interesting, don't hesitate to reach out. Thank you.